Hello everyone, and welcome to this next lecture video in the Houdini Academy Foundation module. In this video, we are going to get started on the creation of our project, set up our Houdini digital asset so we can use it in Unreal, and then we're going to create the ground plane for our building over here. Specifically, if I look at the example file, in this video what we are going to work on is this component over here. And it looks small, but because this is one of the first videos in this lecture, I'm going to try and take it slow and explain the concepts thoroughly so you don't get lost. After that, we'll continue on with the rest of the system here. So let's get started and let's create a new scene. Now, in order to get started, the first thing that we want to do is create a project for ourselves. And this will basically create a new project folder. And I already have a project folder here, which is for the foundation assignment. This here is the example files that come with the project that you can download. But what I want to do is create a new one specifically for our project. Okay, I'm not going to build it inside of the example files. So to do that, let's go to File, and then go to New Project. I'm going to name this project the Foundation Project. And as for its file location, I would like to store it next to our current example file. So in this case, that's located here on my hard drive. So I can just copy this location on my hard drive, and I'm going to paste it in here. And when I do this, Houdini is going to assign this location as the job variable inside Houdini. So we can easily find this location by typing $job anywhere inside of our fields. Next, we also have all these folders that we're going to create, but I'm not going to touch this right now, so let's go ahead and click Accept. And now we've done this, Houdini will let us know that it has set the job attribute to this location, and in our folder, we now have the Houdini project available to us. So in here, all of the folders that were in that list have now been created. Okay, cool. Next, let's go over to the foundation assignment project. And I want to copy a couple of files over. Over here I have the required files folder. Let's go ahead and copy these two folders. And then go to our new foundation project. And in here I'm going to paste them. And this will now put our models into these folders. So here are the models for the rooftop vents. And here are all the textures that we'll need for the assignment. So with that, this project is ready to go. Next, let's go ahead and save our scene so we have a work file to work in. Let's go to File and click on Save. Now by default, Houdini will try to save it in your job folder, which is of course our project folder. We can find it over here with this quick link. And I'm going to call this one the foundation scene. Let's click Accept, and this should save our scene file. So now we have a project inside of the folder. Let's navigate out. Here we go. We have our project and we have our scene file ready. Okay, so at this point we need to decide what kind of digital asset we are going to make. Now in this case, I actually have a combination of instances and models. And my tool is going to be a bit more complex. So I'm actually going to create an object level asset. And if you recall, in case you watch the Houdini 101 series, object level assets are actually really good as main tool wrappers. The ones that you build for your main assets for the Unreal Engine. So let's go ahead and create an object level digital asset. Now to do this, I'm going to work over here in my network editor. And let's create a new subnet in this folder. If I click Tab and type subnet, I can create an empty subnetwork. And this is basically just an empty container, but we're going to convert this into a digital asset. I will call this one the student tool foundation building. Let's connect these two together. And you'll notice my naming convention. In general, I put the name of the project that I'm working on in front. Then I tell it if it's a tool or a utility. The tools being the main tools for the project, the ones that we can use inside of Unreal. And the utilities are the subcomponents that we don't tend to use in Unreal. They are parts of the bigger tools. They facilitate particular features, right? Like texturing objects or calculating certain things. They're basically like Houdini nodes in that way. And then the last part here is the name. Now, my naming convention is camel case, and I will use this everywhere, and I suggest you do too. And camel case is pretty simple. Let me just grab a node here of some kind and show you. This is the foundation project. So I start with the lowercase, and then every other word is capitalized. So that's what I mean with camel case. And I will do that for attributes, and I will do that for groups, and for node names, and everything. With the exception of when I create a digital asset. Okay, so now that I have this, let's go ahead and create a digital asset out of this. Let's right click it, and I'm going to say create digital asset. And when I do this, it's going to ask me the name of the tool. Now I've already given it a name, so let's copy the operator label right here, and let's paste it into the top operator name field. When we do this, it's going to underscore every single word, because operator names need to be continuous. They cannot have spaces, and they also not have special characters. And then next to that, we need to specify our file path. Now we already know that we want to save it inside of our project folder, so let's go ahead and browse. And then next, let's go ahead and navigate to our job folder here. Then go to HDA. And this is the HDA folder of our current project. Now I'm happy with the name. It will be Student Tool Foundation Building HDA. And as you can see, Houdini actually accepts several different naming formats, including OTL. If you ever see an OTL naming format or file type, it's basically like a Houdini digital asset. It's just an older version of it. They do exactly the same thing. It's just another name for it. So in our case, we're going to call it .hda, not OTL. Let's go ahead and click accept, and then accept this as well. And now we have our digital asset. So at this point in our folder under HDA, Houdini will have created a HDA file for us. And this one is going to be our main tool. Later on, we'll import this into Unreal as well. Alright, so the next thing that I want to do is set up the inputs. Now, there's one problem with using object level tools, and that's that they don't actually have input dots. I could specify an input dot here on the tool, and if I click apply, it will create one. However, we cannot actually plug in control curves into the input dots of object level assets. And even if you try to plug it in, it wouldn't work. So instead, what we need to do is create a geometry container and put a curve inside that. And then we'll use a different method to retrieve it. So let's go ahead and create a geometry container. And if we do that, let's go ahead and place it here. And let me bring up the list view so we can see this better. And I'm going to call this one building shape. Now in here, inside this geometry container, I can dive in and I can go ahead and create a curve object. Now let me hide the operator type properties for a moment. Now this curve object will allow us to draw the shape of our building. If you select it with the coordinate field empty, and let me go ahead and show you how this works. I can grab the handle tool here on the left or press the enter key to activate the tool's handle mode, and then I can start drawing. Now I suggest you turn on the grid snap here on the left, or you can press the X key and then bring up grid snap. Now let's go ahead and draw a curve by simply clicking into the screen. And as you do this, you notice that the curve starts drawing points, basically point coordinates, over here on the right. But let me quickly explain to you what these coordinates mean. Over here we have a string of coordinates with very long numbers. But in reality, what these say is -1, 0, 0. And that's because whenever Houdini has to give you a very, very tiny number, it will show it as a fraction using e dash and then whatever fraction number it has. In this case, this is something to the 8th degree. And that's because when we place these points, we snap them to the grid. And in height, well, that basically means that they are almost 0, but not quite. If I go ahead and move this point around, then you see how it does shift. And every time it snaps to the grid, it gives me one of these fraction numbers. We can practically ignore the fact that these are not 0 because they're so fractionally small numbers. But if we want to be sure that everything is flat 0, then in a moment we'll actually flatten this inside of the tool. So everything is exactly at grid height. Everything is going to be at y0. Next to that is basically just a string of these values. So every single time we add a new point or move a point, it's going to add another value to this list. Next to this, the curve node has the ability to output different types of curves. Up here we have the primitive type. Right now it's outputting polygons, but we can also output NURBS curves, for example. And by default it's going to work with CVs. Now in this video I'm not going to explain the details of NURBS curves per se, but they're basically a different type of geometry that creates interpolations between hull points. And if I were to show you the hulls here, you can see how each of the points is connected and it tries to interpolate between those. Now that's about as far as I'm going to go right now about NURBS, because this project is not going to use NURBS. While we could potentially use them for the project, the building might not work properly with them, so I'm going to leave this alone for now. We'll visit this later in the masterclass though. Next, we could also create points, and these just output points without the curves in between. There are other ways to do this as well, such as the add node. For now, all I want is a polygon, so let's go with that one. Then we have the option to close the curve, and when this happens, it will create a plane or a primitive. And instead of creating an edge primitive or polyline, such as this is a single polyline with multiple points, Houdini will go ahead and create a polygon surface. Now the direction, clockwise or counterclockwise, that we drew this polyplane in will determine if the plane is facing upwards or downwards. Basically, if it's forward facing normal, located at its number here, it's pointing down or up. So this is another thing that we're going to have to fix, because I do want my planes to all face upwards. We can actually reverse the curve by hand by clicking on reverse here, and this will change the order in which the points are ordered, or rather the vertex order will be changed under the hood. And when you change the numbering of the vertices in the polygon, the plane will reverse. But in this case, I want to make an automated system that does this for us. So let's go ahead and leave this curve unclosed and unreversed, and we'll deal with it inside the tool, so we actually know it will work. So next we have to deal with the problem of how to get this curve into our object level asset, how to install it basically. And there's a way to do it, but we have to do it in a very particular way, using an object merge. Now if we're dealing with a surface operator asset, it's very easy, because surface operator assets automatically come with their own inputs, and Unreal will recognize those as potential inputs. In fact, we can automatically assign them to be curve inputs if we want to. Now if we're dealing with surface operators, let's create a subnet here. And let's call this the input test. Now this subnetwork will already work to demonstrate my purpose here. I mean, I could plug in this curve, but let's go ahead and show this in Unreal. So I'm going to right click, create digital asset, and then let's just quickly give it a name. I'll keep it in the default folder. Let's accept that. And then by default, this is going to create a surface operator digital asset. with inputs and outputs, so that's fine. And then let me just plug this in, and quickly inside, let's create a ends node, and I'll explain later exactly what this does. But with the ends node, if we set it to close straight, it will enclose my curve. Now if I save this asset by right clicking and going to save node type, I can now import it into Unreal. Alright, so let's go over to Unreal, and here we have the example scene again. Let's look down here somewhere at the bottom, and what I want to do is import the test asset I just created. So in here, in the default My Documents folder, I have this saved, so I can grab it and drag it into my content browser. So I'm going to drop it inside the content HDA folder, right there. Then, if I drag this into the scene, then it will activate the asset. But right now it's not doing anything, it's not drawing any planes, even though we do have something in the asset. If you recall, we added this ends node, but it's not working because there's no input, and that will make the tool throw an error. So, inside of Unreal, what we would have to do is go here to Houdini inputs and switch this to curve input. And the moment we do that, Houdini will create a curve for us, a 2-point curve. We cannot actually delete any of these points. These curves have to have at least 2 points, but we can start drawing with this. So if I click Alt and I start dragging, let's say clockwise, then now we do have a plane. But this plane, well, it's currently inside the ground. So let's grab some of these points and let's move them above the ground so we can actually see what we're doing. Okay, so with this, you can see we do have a plane, but we did actually have to configure it so it created the curve. Now earlier I mentioned that we could actually set it up so it could generate a curve by default. And to do this, we need to make sure that it has the term curve in the name of one of the inputs of this SOP operator type asset. So let's go back to Houdini, and in here I'm going to make a change to this asset. Let's open up the type properties. From here, right click and go to type properties, and then inside of the type properties we can go to input and output, and then here if we type curve and then we go and apply that or accept, then now let's go back to Unreal, go to the input test and right click it and re-import. And this will re-import the asset inside my content browser, but it won't refresh the tool over here automatically. To do that, we have to click rebuild. But of course, I want to demonstrate that it will automatically generate a curve. So let's actually get rid of this asset. So let's click this one, delete it, and let's drop a new one in our scene. And now you can see that it no longer shows the Houdini icon. And if I click the asset up here, the asset component, and now we do actually have a curve. So that's working. Now, in this case, I can go ahead and drag my points out with the Alt key, and it works. But that's not the only thing that the Houdini engine is actually capable of. Because while in Houdini, we only have one input dot, and that means we can only plug in one curve. In Unreal we can plug in multiple. Now of course in Houdini we can create multiple input dots, or maybe grab a merge node and then plug in multiple curves. So if I do that, then theoretically I could have as many of these planes as I want to, right? I could have one here and one there, and this tool will just process both. So we have two primitives right now. But in Unreal, we can bypass this. We don't actually need a merge node, and we don't need multiple inputs, because we can add more right here with the plus button. If I click this, then now Unreal will create another curve. And if I move this one over and draw another curve like this, then now I have two primitives from two inputs, Houdini spline 0 and Houdini spline 1. So this means that Unreal can process multiple curves, multiple inputs in one input dot. But you notice that the entire system that we just built was based on the surface operator type asset, right? So inside Houdini, this is inside a geometry container, meaning that it's a surface operator type asset. We can actually build curves in here. But the moment we want to make this for an object level asset, we can no longer do this. So let's go ahead and create that example too. And in here on the object level, let's create another subnet. Now I'm going to go and call this one the object input test. And let's create a digital asset out of this one as well. So let's copy the name and click accept. Now, just like before, I'm going to add an input dot right here. And let's also go ahead under inputs and outputs and name this one curve. Okay, now let's go ahead and accept that. So that means that right now we have an asset with an input dot. So let's go over to Unreal. And now we need to import it. So let's grab it from our documents folder, drag it into the content browser. And if I plug it into my scene here, then the first thing you'll notice is that it doesn't actually create the input information that we got from our surface operator asset. In fact, the only thing we're seeing here are the default parameters that you would get with a object level asset. It's object container transform and subnet parameter controls. So we can already see that this isn't working, but let me explain why. Let's go back to Houdini, and in here let's go to this object input test here. Let's try to plug in our curves. So here we have our curves, right? They're inside this container. Let's plug them in. So if this was the SOP level context, then now you would think you would have these curves go through this line into our object level asset. Okay, so let's go with that. Let's go inside, and here we have our input. Okay, so next, what do? Well, we can't do anything with it unless we create a geometry container. So let's go ahead and do that too. Let's grab this line and plug it in. And now let's go inside the geometry container. And then what? Well, nothing. Because, and here's the reason, these lines on the object level are not the same as inside the surface operator level. In fact, if I go and create a new, say, box object, right? So this will create a box object inside of a geometry container. And let me just quickly hide all my other objects. Okay. Now, inside of here, I can of course go ahead and add maybe a color node. And let's plug that in. And let's make this something like blue. And let's add an output node as well, so we are sure that this is being output. Okay, just for good measure. Alright, so now we have a box with a color. Okay, now let's copy this. And let's plug these together. Let's move it over. So I'm actually moving the object container in world space, not the model. If I look at the model itself, then in fact it is still at the world center for all it is concerned. It just means that it's at the world center of its own object container. So that's something else important you need to know, is that whatever you see inside of a surface operator asset is based on the coordinates of the object container that it's in. Okay, but that aside, What's happening here is that now we have two boxes, and let's make this one a different color. And the first box is sending data to the second box. But unlike in the SOP context, where we have geometry that then feeds data to the next node, which then processes it, and then feeds it to the next, and then that one processes it, on the object level, that's not what's happening here. On the object level, these links simply parent these two objects together. So if I grab this blue box, box 1, and I move it, then now you can see that both boxes are moving together. And of course the same thing applies if I rotate it. Now the second box doesn't have that transform. It just knows it is transformed at -2. But notice that its own coordinates are now based on the first box, right? If I go ahead and disconnect this, then now it's back in world space, based on the world space coordinate. So all this does is parent these objects together. And it isn't sending information through. This link here doesn't send information from the curve from outside. All it does is bind this geometry object to that geometry object. If I move this object around, then inside you see how our geometry container has effectively also moved. So if I place a box in here, you can see that it's basically bound to where my curve is. That's all it's done. But okay, so if we take all of this into account, then what does it actually mean? Well, it basically means that we need to load this curve in through a different means, through a different method. Now I'm going to get rid of this object input test here and put this back where it used to be. So let's grab this container and put it back at 0, 0. Normally I don't move my containers around. It will mess with whatever we're trying to do in Unreal. So keep it at 0. Okay. But what this means is that if we want to bring this curve into our object level asset down here, then what we have to do is use an object merge. And let me show you how to do that next. Okay, so back here in Houdini, in order to get curves to load into an object level asset, we need to create something called an object merge node. So let's go ahead and right click on this. I'm going to go back to the type properties and I'm going to remove these input dots so we don't get confused here. I'm going to apply that. So it removes the input dot. Because as an object level asset, we need to create object merges inside of this tool. Now, at this moment, this node is completely empty. It's basically just an empty object container, right? There's no geometry in here, and I can't even see where I am. So let's go ahead and turn on the grid so I can actually see where I'm navigating in this menu. If I go to Tools and then turn on Grid Lines, I can now see, well, I can see a grid inside of here, so I have a better idea on where I'm looking and the scale that I'm looking at. Next, let's also turn on Grid Snapping so we can organize our nodes a bit better. So next, let's go ahead and create a geometry container. Let's press Tab and let's place a geometry container inside this node. And I'm going to call this container the building asset. At this moment, we are watching our scene through ghost other objects. That means that we can still see our curve, but it's a bit faded out. So I know what I'm looking at here. Now, what I want to do is import this curve into this geometry container. And we can do that very easily using an object merge. So let's go inside and let's create an object merge node. And the object merge SOP allows us to import any other object into our scene. In this case, we need to reference our curve from outside. So we can do that from this drop down here. If we click on this button, we will open up the operator chooser. As you can see, we can see the network here. And then we have the building shape right there. Let's go ahead and import this with a relative path. I'm going to grab the curve, but I could also grab the entire container if I want to. Now at this point, we have our curve being loaded into our tool, and it will work, except that it isn't ready to be a tool just yet, because we have two problems. One, like this, Unreal won't recognize this as an actual input. For that, we need to promote this to the top level. And second, right now this object merge is referencing an object from outside of the tool network. As you can see, it's inside of our tool here, and it's navigating outside the tool there to the curve, and then it grabs it. As you can see at the top level, we have this reference being created right there. And this would be fine if the reference was being made through the interface of our tool, but right now it isn't. It's being referenced directly from this object merge to this curve, and that is illegal inside Houdini, or at least is not recommended. Let's have a look at the interface of our tool right now. We see that we here have two folders on our tool, and let me go ahead and open up a separate parameter pane for this actually. Let's go to the tool, go to parameters and channels, and then open up parameters. Here we go. So this is basically the same panel, but just floating, so we can keep it around. And as you can see, we do have some folders in here, including some transforms and a subnet. This allows us to control the object level asset. You won't get this with surface operator assets, but you will get it with object level assets. And I don't want to see this. So let's go ahead and change the settings on our asset here. We can either right click on the node and go to type properties, or we can click on the icon here and go to type properties there. Now inside the tool, the first thing I want to do is hide these transform and subnet folders. So let's go ahead and click on them. I'm going to use Control, select them both, and then tag them invisible. And this will make them invisible parameters, so they won't be in our way. And because they are default parameters on the node, we cannot actually remove them. We actually have to hide them. Now next, what I need to do is replace this path that we have here on our object merge inside of our tool. And I'm just going to create a little bit of space here on my scene. Let me drag this over, because unfortunately the edit type properties window is always very big. I can't scale this thing very well. Now what I want to do first is delete this reference. I know that right now we are importing our curve into our tool, but I need to fix this link. So let's go ahead and delete this path. And now what I want to do is import this object1 path here into my tool. So let's go ahead and grab the object1 parameter path here and drag it over into the interface window of our type properties. And when we do this, it now adds it as a parameter, and I want to give this a name. So let's call this one the curve input building. And then the next one I'll call the building input curve. And the reason I gave it the name curve at the start, or at least anywhere inside of the name, is because when the name curve exists on an operator path input that leads to an object merge, then Unreal will automatically detect it as a curve input and will create a curve for us. So inside of Unreal, if I grab any of these tools and I make sure I can see my curves, then you see that at the bottom of the tools, they automatically come with these curve objects. If I go ahead and drag a new tool into my scene, and I let it cook for a second, if I click on the tool, then you see that it automatically comes with a curve pre-installed. Let's go to the Setup tab of the tool. And then at the bottom, you see Building Curve. That's the object merge input, and it's automatically being set. And it's called Building Curve Input. So the one that we just created before as the object merge. Now, as long as it's set to curve, Unreal will automatically recognize it as a curve input as opposed to a default input. But at least this means that now when we drop down a tool, we will immediately see something. So that's what we basically just did. We created a new type of input that isn't directly native to the node, but Unreal still recognizes as an input. Okay, so that's enough for this for now. What I want to do is create a folder, drag it in here, and then drop this one into the folder. And I'm going to call this folder setup. And this is just to keep it all neat. From there, let's go ahead and apply this. And if you click accept or close the window, then now at the top of the tool, we will have a setup folder with our building input curve parameter right here. So that's basically what we would see inside of Unreal, right there. Next, let's go ahead and specify our curve from the building shape. So let's click on this, then click on the curve object or the building shape object. Either one will do. And let's get the relative path and let's accept that. So now we have a properly installed curve inside of our tool, and we are actually ready to start working. Now, if we were to create a surface operator asset, this would be a lot simpler. But for this course, I want to make an object level asset, so I have to show you this. I'm sorry, it's complicated, so watch it again if you need to. But when you understand how this works and how Unreal will process it, you'll be ready and set to make your own object level tools for Unreal. So next, let's go ahead and actually continue building out our tool, because I've spent enough time on how to set up the inputs. Now I do want to make my building space a little bit easier to work with, so I'm going to go up to my building set and change it to my recording layout. And this will give me a slightly different layout to work with. It seems to have removed my grid, so let's bring that one back too. All right. Okay, so now I have the parameter panel on the right, my network view in the middle, and I have my window here and the geometry spreadsheet on the bottom. And I don't really need my timeline or my shelf, so let's hide those. So I have some nice real estate space to work in. Okay, so the next thing I want to do is do some of the cleaning operations that I talked about. Like I said, the curves can be closed and they can create surfaces, and they also need to be flipped up in the right direction. So to do this, let's go ahead and first create a null node, because I like to keep my inputs nicely labeled. Now in this case, I do have an object merge. If this was a SOP operator node, it would be a regular type of input that you would see inside of those. But let's go ahead and link these up and give them some names. So this is the building curve input, and I'll just call this one input for now. And I'm going to color both of these blue, because I consider this to be the input of my tool. This is where my data is coming from, and for me personally, blue is a data color, right? It's a source color. So next, what I need to do is take this curve and close it, so we get a nice polygon plane out of it. And to do that, we can use an ends node. So let's press tab and type ends. And the ends node allows us to take a curve or a surface and either open it up or close it. Basically, connect the ends together or disconnect them. So this allows us to turn a curve into a surface and a surface into a curve. Or at least it's one of the ways to do it. Over here on the right, we have to set this thing to take the close U channel and change it to close straight. And when we do this, it will take the endpoints of this curve and it will connect them. So now we have a surface. Now the next thing I want to do is make sure that this surface is actually completely flat. Because when we're drawing our curve, it's actually possible to draw it in all kinds of shapes. And the moment we turn it into a surface, it's going to become a polygon, and that can cause some weirdness, right? It can cause some weird shapes. So if I go back to my curve, and I grab some of its points and I drag them out, say below the grid here. Maybe I move this one a bit up. Okay, so this thing is no longer planar at this point. It's 3D shaped. It has a 3D shape. So if we turn this into a polygon, like we have here now, you can see how it's no longer a proper flat polygon, and we can't really make a building out of this. We want our floors to be flat. So to fix this, we can use a transform node. And I'll show you two different methods actually to do this. But the transform node is probably one of the more straightforward ones. If I grab the transform node from the menu, I can place it down, connect it up, and in here we have the ability to set its scale in Y to 0. Now the transform node allows me to move this shape around. So for example, I could translate it, or I could rotate it, just like how I described in the Houdini 101 series. But right now, by flattening it in Y space, what I've basically done is I've taken this object and I flattened it to its pivot point. I can move the pivot, and if I do that, I will flatten it to that location. So I could set the scale to 0 on Y and then flatten it in any location as I need to. But in this case, I just want to flatten it to the grid. So I'm going to keep this pivot point at 0. Also, the order in which it applies the transformations matters. Right now, it first scales the object, then it rotates it, and then it translates it. And it also does the transformations in the X, Y, and Z orientation in that order. Now, this is one way to do flattening, and I'm going to call this node the flatten transform. Now, there's another way how we can create a flat surface, and that is by taking the point positions of each of these points on the Y channel and flattening those to 0 exactly. And we can do that very easily using an attribute wrangle node. We can also use a VOP node, but personally I prefer wrangle nodes because they're much quicker and easier to write with. Even though they're a little bit more hard to understand at first, knowing Vex, or at least the basics of Vex, will help you out a lot because you can do a lot very quickly. Let's go ahead and create an attribute wrangle. So just type attrib wrangle and you'll find it, or maybe wrangle. If I place down a wrangle node, plug it in here, what I would like to do is set the point position in the Y direction to 0. And we can do this very easily by typing at for attribute, then P for the point position, and then we can type .y to grab its Y coordinate or its second value. So that's this one here. And then we can say equals 0. And then because it's Vex, you have to add a terminator, which in this case is a semicolon. Now, in order to make Vex accept this code, go ahead and click into the network view or anywhere else on your screen, and it will apply the Vex code and compile it. So now our entire plane has been snapped to 0. Now, just out of cleanliness, I also want to add a V to the front of this attribute, so it always makes sure that it references the point position vector attribute. This just makes it a little bit faster for Houdini to process it, but frankly, it just makes it so that if you're dealing with strings or some other more complex attributes, Houdini is sure what you're actually talking about and it won't error out on you or try to grab the wrong type of attribute. Better to make this a default practice. Try to add the type of attribute in front of it when you're writing Vex. I'll show you the other types as we write more Vex code, or if you follow the Houdini 101, then you'll also have a better idea on what I'm talking about. But don't worry, we'll get to it. Then next, what I want to do is check if this object is reversed. And to do this, we can do this very quickly using a group expression node. Now, the group expression node, just like a wrangle node, allows us to create a little script, though a very simple one, that can check if a certain condition is true. Now, in this case, what I want to do is grab this plane, grab its normal direction, which we can find. It is present because it is a polygon, and because it is a polygon, it has a normal, a forward-facing normal. This is the front of the plane. So the normal of this plane currently is pointing down. It's pointing down towards negative y, right? So positive y is up and negative y is down. If I look over here in the primitive attributes, now right now we cannot see the normal coordinate. If I go ahead and create a normal node and I plug this in and I set it to primitives, then it will expose my current primitive normal for this plane, for this polygon. Now you can see how the y channel is set to -1. So this is a way for us to recognize if a plane or surface is upside down or not. And we can do this very quickly using a group expression to filter those out. In this case, what I want to do is create a group when the plane is upside down. Now I want to see my groups, so I'm going to open up the group display and attribute list down here. And it's currently set to the star symbol, meaning that we'll select everything. And then next, let's go ahead and write a little group expression over here inside the group expression node. We need to make sure it is set to primitive type, because I want to select the primitives that are upside down. And then I want to create a group called flip. Let's type this, flip, right here. And inside the expression, I want to access the normal attribute. Now, as you saw, when I create a normal node, it actually exposes the normal attribute. And the normal attribute is a default attribute on any geometry. It's just hidden most of the time, but it is actually there. So in this case, what we can do is say vector attribute normal, or n. And if this in the y direction, dot y, is less than 0, then I want to group it. And if I click somewhere in the screen and accept this script, now you can see how it's creating a group called flip on my geometry because it's upside down. Alright, cool. So now that we know this geometry is upside down, we can very easily reverse it using a reverse node, right? Clever name. Let's go ahead and create a reverse node. And this one flips around the vertex order of our surface. But right now it's applying it to everything, so we still need to apply it to the actual group. So up here in the group field, let's say flip. And that should ensure that we are applying the reversing operation only to our grouped geometry when the plane is actually upside down. Okay, so this method is pretty accurate in that it will always select everything below the y direction. So if we have any plane that is even remotely pointing downward, it will be selected. But let's say we want to grab an arbitrary direction, right? And we want to select everything within a certain range of that direction. Well, for that we can use a different method. And for that we can use the group node. Now, if you followed the Houdini 101 video on groups, and you already know this one, basically, if we were to grab a group node, a group sop, and let's call this one flip as well. And then I'm going to switch it over from base group, which will select everything right now, to normals. And then in here, I can now specify a direction. Now by default, it's going to point towards positive z, which is to the left, right? And if I were to take my spread angle, and I decrease this, then at some point it's going to stop selecting my plane. Right now it is. And that basically means that our plane is pointing downward. And our selection direction is left. So if I start at 0, then it will only select things that are pointing pretty much straight to the left. But if I go and expand this angle far enough, and once we go over 90 degrees, we will start selecting this plane. So we will, select this angle range here, everything pointing towards this direction. So we can use this, of course, if we grab the negative y direction and then select a reasonable angle. So we could select everything under 90 degrees, but let's pick everything under, say, 89 degrees, okay? And then, of course, this will also allow us to select everything that is upside down, just the same as we did with our group expression node. Now, I'm not going to keep everything here in my scene, so I'm going to get rid of this again. And instead, next, let's have a look at another method. And this is the last one. Now, in case you want to write this same code using a wrangle node, I'll quickly show you how to do that. Let's go ahead and create another wrangle node. Let's plug this one in. Now, normally we could probably write this script in the same wrangle node. I mean, you don't have to be limited to writing just one line. We could write a lot of lines of code in one wrangle node, except that in this case we need to run over the primitives, and this one is processing the points. So the second wrangle node I'm going to set to primitive mode, and this one's going to process every single primitive in our geometry here. Right now we only have one, but that doesn't matter. And we can add a group called flip, the same way how we did it in the group expression node, by typing @group. Basically, the way to create a group or reference a group in Vex is by typing @group_, and then specify the name of the group. Then I'm going to say equals, and then I can write either a small if expression, or I can just give it a number, so it's 1 or 0. 1 will set the group, 0 will not set the group. But if I write in between brackets here a small condition, v@n.y is less than 0, then now this wrangle node is going to do the same thing as our group expression node did before. So in this case, it has actually grouped this plane. This is how you can write it with pure Vex code. Anyway, let's continue, because I do want to wrap up this particular video. Next, let's go ahead and take these nodes. These are my clean nodes. I'm going to get rid of this normal node, by the way. I'm going to grab these, drag them down a bit, and we're going to put these inside of a inside of a netbox. Now, in order to create a netbox, you can either click up here, but because my screen is very thin, some of my buttons have disappeared. If that happens, of course, you can also type Shift-O, and this will create a netbox for you. Now, the netbox is basically just a little wrapper that we can put around our nodes, allows us to keep our network nice and clean and organized, and I'm going to use them a lot. I'm going to call this one, this netbox, the floor plane. Okay, so now that we have our plane, it's flattened and it's reversed, we are now ready to start working with it. And the first thing that I want to do is carve this thing into a couple of lines. So we just created a surface. Now I'm going to carve it into lines. Well, you'll see why. Okay. So let's go ahead and create a convert line node. And the convert line node, if we plug this in, is going to take our polygon and take all of its edges. So that is the edges between the points. And it's going to carve it all up and turn them into individual little primitive line objects. So now you can see down here, we have a lot of them. Also, the convert line node has the ability to calculate out the length of every line automatically. It's a small but useful node. In general, if you need to carve up a line, this one's a very quick and useful way to do it. Now the next thing I want to do is take these curves and I want to subdivide them. Because all this has done right now is it's taken my points, the ones that I've drawn, and it's created individual lines for each of those. Next, what I want to do is take each of the parts of my building here, each of these tile rows, and I want to subdivide it so I have windows between all of my points. To do this, we can use a resample node. And the resample node allows us to take any edge and resample it with more points. So in this case, if I plug this in, it's going to try to resample it by 0.1. Now, word of caution, if you're using a very large object, by default, if you plug it in with a 0.1 value, Houdini might slow down a bit, okay? It might even freeze up completely if you feed it a lot of data and a very large amount of very large objects. Best case in that case is to either change the value before you plug it in over here, switch it to something more acceptable, a larger value, or keep your Houdini session in manual mode so it doesn't update, plug it in, change the value, and then turn it back on. Anyway, that's just a little word of warning. But as for the resample node itself, what it does is it takes any line or any edge, like I mentioned, and it subdivides it. Now let's go ahead and have a look at the length value here. Now by default, the resample node will try to resample every polygon line or polygon edge as accurately as possible to this length. But it's also going to try to make sure that all the segments have an even length. If I look closer to this line here, for example, number 4, and I increase the length value, you see how it tries to keep it evenly spaced? And if I go big enough, at some point it just disappears. Now it's doing this because right now we are working with polygon primitive lines that are only this long. Let me turn off the convert line node for a second. And if I do this, then now it treats the entire edge around the polygon as one giant curve. And now it's doing some different behavior. If I increase the value here, the length, it no longer maintains its original shape. And that's not something I really wanted to do. Now, we do have the convert line node here, so we don't have to worry about this per se. We are dealing with polygon lines after all. But if you want to make sure that it does maintain the shape of your polygon and has the same behavior, you can turn on resample by polygon edge here. And when you do that, it's going to treat every single edge as its own segment for a larger polygon. That's how you can make sure that it resamples the surface properly. Let's turn this back on. And I make sure that resample by polygon edge is turned off. Then down here we also have the ability to change the way how it resamples individual edges. So if I turn off the even last segment same length option, you see how it stops building that last part of the line. And that's because this one couldn't reach the exact length of 0.18. Now if I turn on maintain last vertex, it will build that last segment. And this basically allows us to resample a line, along the direction of the curve. So we have a lot of options available to us, and these are just a few. If we take a curve, like a NURBS curve for example, let's create another curve node. And if I draw this one into my scene, so by default we are going to be creating a polygon line again. Let's go ahead and switch this over to NURBS objects. So we now have a NURBS line being created. And now if I grab a copy of my resample node, and I plug this in, then you'll notice how it now resamples the NURBS curve instead. And this allows us to turn a NURBS curve into a subdivided polygon line very easily, because the resample node only outputs polygon lines. That's something to remember. Now if I do a length resample, we can see that we make some very nice curves, and because we've maintained our settings here, so that is a even last segment same length and maintain last vertex, these two, we do sort of build this line along from the beginning to the end. So this can be pretty useful if you need to create paths, or if you need to create like smooth curves that have been properly resampled. There's even more settings to go through here. We can output attributes. We can use that to find the direction of the curve and the left and right side, but that's not what we're trying to do right now. So let's continue on with the resample node right here. So I'm going to turn this one back to use the even last segment length. In fact, I'm actually going to turn on resample by polygon edge again. This will disable that option. So now we have our curve properly segmenting each one of our segments. Now next, what I want to do is set up this value to something we can actually use and then promote it to the top level. So by default, I'm going to set this value to 2 because I want most of my tiles by default to be 2 meters wide. And now if I go to the foundation tool type properties, I can go ahead and drag the length value from this node, the resample, in here. So let's go ahead and create a new tab inside of my interface, and this one's going to be specifically for the main building settings. So we have the setup tab, and then here we have the main building settings tab. Let's call this one building settings. And I'm going to grab this length parameter and drag it into that folder. And I will call this one wall segment width. I'll just give it a nice name as well. Okay. Now as for the range, you'll notice how by default it cannot go below 0. Well, that makes sense. We cannot really resample a curve below 0. But I don't want it to go that low. I don't want my tool to create really tiny segments for our walls. In fact, let's make sure it cannot go below a value of 1 in this case. So let's lock it at 1, and we can leave the maximum value at 5. That's fine. And just to check, under channels, our default value is going to be 2. So with that, let's click apply, close the window. And now, if we bring up our parameter panel, you will now see that we have a wall segment control right here. So if I go ahead and drag this around, we can now control the dimensions of our curve. Now our curve is a little small in my scene, so let me quickly go and size it up a bit. Let's go to the outside of our building tool, grab our curve, let's grab the handle tool, and I'm just gonna move around my points a little, give myself a slightly bigger building to work with. Okay. All right, so that should be enough. And I'm actually gonna remove that point over here. So we should have a nice and clean building shape. Okay, so next let's move on. Next, what I want to do is take each one of these subdivisions and again carve them into individual segments. Now we already did this before. We can simply use a convert line node and drop it in below the resample. And just before I continue, let me go ahead and name these nodes. So I'm going to call the group expression node the check if reversed node. The reverse node here is going to be reverse flip group. The convert line node will keep the same. And then the resample node, I'm going to call this resample by segment width. Now this particular node has a control on it that's being promoted to the top level. And I want to color this node yellow, because that's my personal naming or color convention for nodes that have some kind of parameter on it that can be changed. I don't always use it, but it does allow me to recognize that this node is being controlled by another parameter from outside. And that's a good thing to do. And then, like I said, let's go ahead and grab a convert line node and plug it in below. Now in this case, I do want to make sure that compute length is set up, and I want to change this name. I'm going to change this to width, because I wanted to output this attribute as a width attribute. Now, as you can see, it's now outputting two attributes right here, the rest length and the width. And also the rest length is now 0, because our second convert line node has destroyed the attribute. So this is something that some nodes in Houdini tend to do. the convert line node has a tendency to destroy some attributes. Now there's another way to carve up a line, the similar way how the convert line node does, and that's by using a carve node. Let's go ahead and create a carve node. And the carve node, plug this in, allows us to take a line and segment it based on a distance, or rather a percentage, along the curve. So every single primitive here has a distance along it. And let's say I turn both on here. You can see how I can basically unroll or keep only a part of each individual curve as a percentage. That's useful in some cases. But in this case, what I want to do is I want to set both the first U and second U, make sure they're both turned on, and then set them to 0 and 1 for the full range, and then go to breakpoints. And then under breakpoints, go to cut all internal U breakpoints. And when we do this, it's going to have the same effect as the convert line, except it doesn't destroy our attribute. So the convert line node actually did destroy our rest length attribute right here that came from the node above when it did its carving. And the carve node doesn't do that. Now the carve node again has its own issues, so usually I need to flip between these two depending on the situation I'm working with. Now the carve node does have the tendency to not carve every single segment. It's a little bit bugged, and the easy way to get around that is by simply putting a second one right below it. Basically, sometimes it doesn't completely carve up every single segment, and maybe these two are combined as one primitive object. Putting two of them in a single line, like this, will bypass that problem 100% of the time. And then last, of course, because we don't have the measuring feature of the convert line node, we can also create a measure node. And the measure node will allow us to grab the length of each segment. So it will write it to every primitive, which in this case is every single segment here. If I go ahead, I can grab every single line, and I can write a width attribute to those. So over here under the measure node, we can set the measure node to perimeter, and this will calculate out the perimeter of every one of our lines or of the edges of a polygon surface. And in this case, if I change the attribute down here to width, it will do the same thing. So you can see how there are two different ways in Houdini here to do the same thing. We have the convert line node, and then we have the carve nodes with the measure. Both do the same thing, except one does not destroy the attributes that come into it, and the other one doesn't have the buggy issue where you need to line two of them up in a row to make sure that it carves up everything. In general, there are a dozen ways to skin a cat in Houdini, pardon the expression, but usually there's one good way, or one way that is more efficient, or doesn't destroy your attributes, or keeps your groups intact, and knowing how these work is very useful. And I will cover a lot of this during the masterclass. So, keep watching and you'll learn something, right? Now, okay, at this point we have our lines, but we lost our surface. Well, we can fix that. First thing we need to do is reconnect every single one of these lines together, because both the convert line node and the carve node disconnect all your points. Right now, every one of our points here is a disconnected point. And to fix that, we can use a fuse node. So let's grab a fuse node and plug this in below. And what this will do is, based on a certain distance, it will fuse all of our points together. So now we have a single series of lines that are fully connected, just like we originally had. Now we still have some of our attributes down here, including the rest length and the flip group, which are pretty much useless at this point. So let's go ahead and clean those up. First, I don't need the rest length from the original convert line, So I'm going to turn this off. That gets rid of that attribute. At least over here in the fuse node. And then next, we have this group. Now I don't need this one anymore. So I'm going to create a group delete node here. And clean this one up too. And I'm going to specify the flip group to be removed. Now this node is a deletion node. So I am going to color it red. And I will call this one delete flip group. Okay, so next let's go ahead and create a polyfill node. And the polyfill, if I create one, allows us to take a edge group or a series of edges like we have here and recombine them into a polygon surface. Now it's going to try and do this based on circular connections like this. And in our case, it's a very simple situation, so we don't really have to worry about it. But what I do want to do is make sure that it doesn't do this quadding, try to make it into a quad surface. So over here on the fill mode, I'm going to change this one to single polygon. And now we have our surface back, but we still have our edges. And that's good because I want to keep them. But right now, all of the edges and polygons are connected to one another. They're all part of the same mesh, basically. Each edge here shares the same points as the primitive surface. If I move this around, then now we have both our surface and our edges as primitives connected. Now normally you don't actually want to go and do this, but in our case, I want to split them up, right? I want to filter them out, each one. And we can do this very easily by creating a group right before we use the polyfill. So let's go ahead and create a group node. And I'm going to plug it into the polyfill node right before it. So let's name this group the edge group. I'm going to name the node first. And up here under the group name, let's call this edge. And it should be a primitive group because I'm trying to group my primitives here. And what this will do is it will create a group, a primitive group, specifically for my edges. And then when I use my polyfill, it's going to fill in those edges with a polygon, but the primitive group edge will not be transferred over to the polygon when it's created. So this will allow me to easily filter them out. Now at this point, we've pretty much finished this part of the lecture, and we'll continue in the next video. But before I finish up, I quickly want to clean up the last parts of my network here. So let's go ahead and give some names to some of these nodes here. First we have this convert line node, and this convert line node is also creating our width attribute. So it's creating an attribute, so I'm going to color it light blue in this case. In this case I'm going to call it convert line width. Then next, down here, I have the edge group node. Let's go ahead and give this the green color, which is the color I tend to use for nodes that affect groups. Now we could do the same thing up here with this group node as well. So now that we have all of this set up, there's one last thing that I want to add, and that has something to do with how Unreal processes curves. When we import our curves from Unreal, they will have a scale attribute on them. And later on, it's going to bite us in the behind if we don't clean this up before we feed it into our tool. I've had this break my tool before. So what I want to do here is go ahead and create an attribute delete node. And of course this is a deletion type node, so I'm going to color it red. And I will call this the remove, scale, and rotate attributes. So in here, let's plug this in. And I want to make sure that this node removes the scale and rotation attribute before we feed the curves from Unreal into our tool. And like I said, if we don't do this, then it's going to give us a 0 value for the scale And well, basically down here, these attributes, there's going to be a scale and a rotation attribute as well. And those are going to be fed through our system. And then later on, it's going to play with our systems. It's going to play with our nodes. And it's going to cause things to be scaled down to 0. And it's going to break a lot of stuff at the weirdest places. Okay? So that's one tip. If you're plugging in a node from Unreal, I suggest you remove these attributes. Okay, so at this point we are ready. Let's continue in the next video. And in the next video, we are going to focus on the exterior walls. So over here in my other scene, let me drag this over. Then here in the example project, you can see how I'm taking the edge that we have from our building, and I'm going to extrude it up. And I'm going to do this for the floor height, and then I'm going to copy it later on for every single one of our tiles. And then we'll start processing it for other parts, such as which parts are going to be corners, which parts are going to be walls. We'll deal with that in the next video. I suggest you go ahead and save your scene. And lastly, let's go ahead and go to the tool itself, go to Save Node Type, and save the changes of our asset. So now it will have saved our changes and stored it inside of our building HDA. So thank you for watching this video. So I hope to see you in the next video, and have a good one.